Chapter 4, Section 6, Simplifying Radicals. This is just the beginning of Chapter 4, Section 6 because the rest of it will just compound on this. So we're just going to begin with 4-6 and talk about it now. So first let's just review. A radical or a root is also known as the square root in this case because the index is a 2. When there's nothing there, we assume that it's a square root or that the index is 2. Okay, what we're going to work on today is how to get the simplified form of a radical. Okay, if you have something like this, we're going to change it and we're going to make it into something like. So simplifying radicals, steps to simplifying radicals. First thing we're going to do is we're going to rewrite the inside number as a product of numbers using the largest perfect square, okay, which that's what it says behind the video. Simplify the perfect square and continue to rewrite as a product of, I can't remember what it says there, product of numbers, and then multiply all the numbers on the outside and inside of the radical so that it is simplified, and then it's going to look like this. So you're going to have a square roots of x, where this is your simplified and this is what cannot be simplified. Now, before we do any of that, you guys need to know what perfect squares are. Okay, so let's talk about perfect squares. 1 squared is 1, so 1 is a perfect square. 2 squared is 4, 4 is a perfect square. 3 squared is 9, 9 is a perfect square. 4 squared is 16, which is a perfect square. Then I have 5 squared, 7 squared, 49, 8 squared equals 64, 9 squared equals 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196. Make sure I don't mess this up. Yep. 15 squared equals 225, and then 16 squared equals 256. Okay, so what I want you to recognize here is that all of the numbers here, these are all perfect squares. Okay, all the red. The square root of 25 is 5. Okay, the square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. Okay, and that's why I'm highlighting all of these, because we're going to be using those to simplify. So let's simplify the square root of 54. What I want to do is I want to break down 54 until I find a perfect square. So I'm going to put the square root of two numbers. Well, I need the factors of the numbers. So if you don't know the factors of 54, you can write them out, or you can go to Factor Finder. So I have 1 and 54. I have 2 and 27, 3 and 18, 4, 5, 6, 7, 8, 9, and 6. Oh, there it is. Okay. If you look for the highest perfect square in those numbers that we had underlined in red, the highest perfect square is going to be 9. Okay, so I'm going to put a 9 in here, 9 times 6. And now I have my perfect square. So I'm going to split these up so that my perfect square looks like this. So I have the square root of 9 times the square root of 6. Square root of 9 is what? Well, we just talked about that. The square root of 9 is 3. Okay, so I'm going to rewrite this square root of 9 as 3 times the square root of 6. And that's as simplified as it gets. Let's do another one. 76. Square root of 76. Oh, no. What times what gives me 76? Well, let's look at Factor Finder and see how we can use that. So here we have Factor Finder. All we have to do is enter the number 76, and it gives me, it lists them all. What is my highest perfect square inside of that? It's 4. So let's go ahead, 19 times 4. So I have 19 times 4, which is the square root of 19 times the square root of 4. The square root of 4 is 2, and then I have the square root of 19. Now I always write, you want your 2 in front so that you don't accidentally assume it's underneath the root. So it's 2 square roots of 19. 180, I need to find perfect squares, so you can go to your factor finder if you want to. Put in 180. Find your highest perfect square that's on that list that we made earlier. It'd be 36 and 5. So I'm going to go back, put 36 times 5. Then I have the square root of 36 times the square root of 5, which in this case is 6 square roots of 5. Now we've been using this skill so far as we've been simplifying radicals, but let's just talk about it again. Okay, when simplifying square root expressions, a radical, remember, is just that symbol, also known as a root. Any product or quotient under one radical can be separated into 2 radicals. Likewise, if 2 radicals with the same radicand being the square root or cube root, can be combined under one radical. So if we look at the examples here, if I have the square root of 8 times the square root of 12, I can combine those underneath one radical like this. And now I can multiply those two. 8 times 12 is 96. And then you can simplify it down the exact same way you did before. So I have the highest perfect square. If you're not sure, you can go to the factor finder and find your highest perfect square, which is going to be 16 and 6. Which is 4 square roots of 6. Now I went ahead and broke this up right away, and I can do that because of the what we just talked about. So here we have them together, 14 times 21. Now if I multiply those together right now, I'm going to get a really, really large number, and I don't want a really, really large number, so I'm going to break them up inside. So I'm going to have this be 7 times 2 times 7 times 3. And now I can put them together however I want. I could put 7 times 7 here, and I could put 2 times 3 here. And what happens is, now I have the square root of 49, and I did that on purpose because 7 times 7 is a perfect square. And 2 times 3 is 6, so I have 7 square roots of 6. So it's really helpful to be able to split these up and put them together to make it easier to simplify. Same thing can be true for division. You can always, I always tell my students to make sure and divide this up right away and see which one is going to be easier to simplify. I'm going to look back and say, okay, are those perfect squares? No. So I probably don't want to simplify this one since it's not a perfect square, but I do want to simplify this one because 48 divided by 3 is 16. So that gives me the square root of 16, which is a perfect square, at 4. Much easier to simplify than this one. Okay, now this one. Are 15 or 5 perfect squares? No. So I want to go ahead and combine those underneath 1. That way I can simplify that. 15 divided by 5 is 3, which is just the square root of 3. Finally, solving equations with perfect squares, solving equations with square roots. I'm going to divide by 4 like I would in a normal equation. So I have x squared equals 121. The opposite of squared is square root, so I'm going to take the square root of both sides. Okay, and I'm going to get x equals. Now here's the tricky part. Okay, don't ever forget this because this is true for anything with a even radicand. Okay, since we're finding the square root, when I square a positive or negative number, I'm going to get a positive. So think about this. The square root of 121 is 11. Okay, however, the square root of 121 is also negative 11 because if x squared equals 121, if I take negative 11 and I square it, I'm going to get 121, which is positive. If I square a positive 11, I'm also going to get 121. So that means I have 2 possible solutions inside that for x that can equal 121. So anytime you take the square root in an equation and use it to solve, you must have positive, negative 121, or square root of 121, which in this case would be positive and negative 11.